Well, can you see that?
Please, sir, don't forget what we were talking about yesterday.
Oh, yeah. All right, I'll talk about that at the end, because then we'll have everyone. So, hi, Catherine. You remind me, Sam, if I forget. Okay, so I want to see what you guys think the answer is of this one. So this is a past HSC question. So we've got point P. Which one is it? A, B, C, D, or, yeah, no, E. Sorry, I was getting a bit carried away. What is X in this realm, in this world? What does it mean?
Displacement.
Displacement, yeah, awesome. All right, so, okay. So, welcome to everybody who's come in late. We're just trying to answer this question. It's a past HSC question. So see if you think it's A, B, C, or D. I'm going to give you another 2 minutes to decide. And I just said, what is X in this world? It means displacement. Good to see you all, by the way.
Oh, yeah.
So I'm going to ask Mitchell what he thinks, because he was stretching. Which one do you think it is? Or have you got part of the answer there?
Hang on. Is it A?
Who said that?
Sam.
Sam. It actually is. Do you know, can you explain why?
I'll explain the acceleration is because it's a cubic graph, and you derive it once, gives you velocity, derive it again, it'll give you acceleration, and the acceleration is a straight line upwards. Like when you do the second derivative of that graph, you get a straight line going up.
Yeah, you will.
Yeah. And the negative velocity for the first derivative. I don't know how to explain that, but I just did.
Can I show you this? So if I do the tangent of P, can everybody see that I've done that? It doesn't look like it's appeared on the screen.
It didn't.
Yeah, no.
Oh.
Let me draw so it's all good. I got you.
I'll stop sharing. I'll do it again because this happened yesterday. We might have to do it a few times. All right, can everybody see the tangent that I've drawn?
Yeah.
Yeah. So what happens when I do the first derivative, I'm talking about the tangent. Now, is this tangent positive or a negative?
Negative.
Negative. So it's in between what two questions? A and B, because the velocity is the first derivative, isn't it? What's the second derivative?
Acceleration.
Acceleration. So if you've done the first two lessons, you know what I'm talking about. So it has to be negative, all right? Now the question is it positive or negative? Now, if I take this off, it's not allowing me to do this. There we go, it's off. At point P, what's the concavity like?
Positive.
Positive, isn't it? And remember, the double derivative, what does it tell us? What's the only thing that it tells us? It tells us acceleration, but when we go back to calculus, what does it tell us?
The concavity.
If it's positive, what does it tell us about the concavity? It's concave up. If it's negative, what does it tell us?
Concave down.
Concave down. So it has to be A, because what's the concavity at P? Positive. Does that make sense?
Yeah.
Yeah.
Yeah. So these are the questions they're asking more and more about understanding, all right? So if you understand that the double derivative talks about concavity, then you realize that. So, and they go, oh yeah, in this situation, the double derivative is acceleration, all right? Any questions on that? Put thumbs up if you get what I'm saying on the emoji. Can you do an emoji?
Oh.
Yeah. So we've got 1, 2. Logan, do you get it? Yeah. Mitchell, you get it?
Yeah.
we've got everyone on board. All right, second slide. I want you guys to try to do this. So this is an interesting question. This was from 2013, the exam. Now, 2013, you won't have to do it all because the course has changed, but it's a question, it's an exam that I get to try, my top students to try some of the questions because there's not a natural flow to what other exams are like. So this one can be quite tricky, especially part 4. So think about it. I want you guys to get started with this. Don't do it on my screen, please.
So I can't be bothered getting me a book yet.
Give it a go. All right, I'll start in about 4 minutes. No, 5 minutes. I'll start doing this question. All right. And there is, just so I don't know if you can see, there is a dot on top of this one. So what does that mean?
It's already the derivative. Like
so
it's
it is
derivative of
velocity.
velocity.
Yeah. Yeah, Sam, do it on a piece of paper or something. Go get one. So.
No.
Sam don't want it.
Hi, Mason, by the way, sorry.
All good.
Careful, Catherine, I'm allergic to cats. So. All right, I'm going to be bored, so I'm going to do part 1, okay? So part 1, we need to find acceleration. What do we have an equation of? Displacement, velocity, or acceleration?
Velocity.
Velocity. So I just have to derive it once, don't I? So. A constant is probably bad. Acceleration is constant. If we get a constant solution for acceleration, it's constant. So it's this constant, you've got your foot on the pedal in exactly the same spot. You're not changing it. You're not accelerating really fast and then pulling your acceleration back and then putting the brake on. You've got your acceleration at the same spot. Okay. So yeah, we derive a 1, we get acceleration, and we get a constant. How many marks is that? 1 mark. That's pretty good for 1 mark, isn't it? Pretty easy. When will the particle be at rest? What needs to be 0?
Velocity.
Velocity, yeah. When your car is parked in the street, what's the speed of it?
0.
0, isn't it? That's why it's at rest, all right? So don't get mixed up with acceleration, all right? I can have 0 acceleration and the thing can still be going, okay? Because what happens is that if I start driving down the freeway at 110 kilometers per hour and I take my foot off the pedal, so I've got 0 acceleration, will the car keep moving?
Yes.
Yeah, it will. So the only way we can know if the particle's at rest is if velocity is 0, okay? So substitute V equals 0. I'm going to start doing that now. Same thing, isn't it? Okay, for part 3, when it says position, what are we looking for? When it says position?
Time. Displacement.
Displacement, isn't it? So what do we have to do to our velocity? What do we have to do to our velocity function?
What do you call
What do we have to do, Mason?
Integrate it.
Integrate it. So I'm going to do that. I'm just going to copy this over to the other side. Hopefully you can see it. So there he is. Anyway, I'm going to get something with plus C. How do I find out what plus C is?
Initially the particle is 5 meters to the right.
Yeah, so at T equals 0. And what is it? X equals what? Positive or negative 5?
Positive.
Positive 5, yep. How many marks have we earned so far? 4, haven't we? Who thinks they were very challenging marks?
Oh, I can't see them. Yeah.
You can't see them?
No, it's just the
Oh yeah, the same with mine. But if you pull it down, hello.
Hi.
If you pull them down, then you'll see the marks. So we've earned 4 marks so far. All right. Now, what also you've got, I want you to notice is that this is question 14. All right. Now, your exam will follow a different flow, but what I want to talk about, where are we in terms of difficulty of questions? We've done question 11, 15 marks. We've done question 12, 15 marks. We've done question 13, 15 marks. So we're 45 marks into the exam and we get this question. We're in a pretty good position, aren't we, if we're getting these pretty straightforwardly, all right? So if you're confident with these, do a few more to make sure that we're getting all those marks. All right, this last question is a tricky one. So I want you to see how you go with it. Okay, I'm going to give you one more minute, and then I want to hear answers from question 4, and then I'm going to explain it. All right, has anyone got any answers for question 4?
21 meters.
21 meters. Ooh, that sounds close. I'm going to write them up here.
26.
21 meters, 26 meters. That sounds pretty good. Anyone else? I actually forgot
26.
what the answer is, but
26.
26, so we've got 2 for 26. I do have them written, but you're just, if you got your screen over there, you can see, oh, it's lagging anyway. So.
Yeah.
All right. Well, let's give it a go. All right. What I'll do is I'm going to disconnect again and then connect it again because it seems to struggle. All right. Okay, so what I want to know is find the distance traveled in the first 7 seconds. I actually want to know this. Can you see what I've got highlighted in yellow? That's my displacement. So that's the curve that it's traveled, isn't it? And it's actually a parabola. And what type of parabola is it? Negative or positive?
Negative.
Negative, which means it looks like this, and it will have a maximum distance it's traveled. I want to know where that is, okay? And the easiest way to do it is go t equals minus b over 2a. Do you remember using that?
Yeah.
Like, it's not t, it's actually x, isn't it? Like when we use it. So minus b will be minus 10 over 2a will be minus 1. Is that right? Minus 2 times 1. So it's at t equals 5 seconds that this occurs, doesn't it?
So why don't you just do the old classic calculus way of letting x
You
up?
can. So
Yeah.
what's the other way? Is that we can make v equals 0, isn't it? Because it's a derivative. That velocity is the derivative of displacement. So that's the calculus way that you're talking about, Sam, is it? So we're going to use this guy, make it equal to 0. And we've actually worked this one out already. Essentially, I want to know where is its maximum point that it's traveled to, okay? So at what time is that it is at its maximum? Is at t equals 5, okay? So I'm going to go sub t equals 5 into my displacement formula. Does anybody know why I'm doing this? So what's that? It'll be 55 minus, is it 30 meters?
Sir, how, if it's a parabola and
Yeah.
one of its resting points is at t equals 5,
Yeah.
how can that also be the turning point when there's two resting points at the bottom of the
There's two what?
the two x-intercepts,
Yeah.
they're the resting point. How is
not for displacement, only for velocity. You're confusing things. So we're looking for the turning point. Just think about looking for the turning point. Don't think about your x-intercepts at the moment. All right. So let me draw what's happening. I'm going to rub this off on this side so you can see, yeah, it's working well. So this is displacement, okay? This is the origin, O. Where do we start?
5 meters after that.
Yeah, and we traveled all the way to what?
26 meters.
To 30 meters, didn't we? So we've traveled to 30 meters. So that's at t equals 5. So what does the question want to ask us? The first 7 seconds. So let's find out what is happening at t equals 7. Where is it? Okay. So let's go x equals, and let's substitute into our displacement formula again. That's 70 minus 49 plus 5. So 70, is that 26?
Yeah.
So where is it now? Down here.
Yep.
How much has the ball traveled?
21 meters.
It's gone 25 meters, hasn't it? This way.
Oh,
And then what's happened? It's traveled another 4 meters that way, hasn't it?
Oh.
how?
Well, it says it goes find the distance traveled of the ball. Okay. In the first 5 seconds, how much has it already traveled?
In the first 5 seconds at the top of the parabola.
Yeah, so
That's
imagine
25.
Imagine this is a ball that's going side to side. It starts at here. This is why I picked this question, because it's an interesting one. It starts here, doesn't it? Then he travels all the way to 30 meters. So it's traveled 25 meters, hasn't it? That's in the first 5 seconds. In the 2 seconds afterwards, what has happened? It's traveling back, isn't it? So it's hit a wall, an imaginary wall or something, and it's coming back.
I did put that one on.
So distance traveled
I did put that one on.
will be 25 plus 4 equals 29 meters. Okay. Any questions on that? Does that make sense, Mitchell?
Yeah, it is.
Huh?
Sure.
What did you say?
I'm full space cadet today, sir.
Alright. I'll send it to you guys anyway if you want. Does that make sense, Sam?
Kinda. Just don't really get how on the displacement time graph and the velocity time graph you can like use 5 for both. Because one's an x-intercept, the other one's a turning point.
No, they're both the same thing. So all I'm looking for is this guy here, the turning point. And there's just a couple of methods I can use.
Yeah, but with the displacement time graph, you make x equals 0, the t equals 0 and 5, meaning they're the x-intercepts.
In the displacement one or
Yeah.
the velocity one?
Displacement one.
No, you'll find that the x-intercepts are different. So
Yeah, I get that. I just don't understand like why it changes.
So what was it? It was minus, it was 10t, wasn't it? Minus t squared plus 5.
Yeah, thanks. Yeah, thanks for that. Bye.
See if you can factorize that one. And then you'll find the x-intercepts of the displacement thing. So factorize it. Yeah. Mason, did that make sense?
Yeah, it does, sir. Yeah.
Catherine? Logan?
Yeah, they're all good.
Ellie?
Yeah.
Did it make sense?
Yeah.
Jack?
Yep.
I don't know where Jack's gone.
What?
Yeah.
Yep.
All right, awesome. Let me show you something. I'm going to stop sharing that, and I'll see if I can share this. Oh yeah, I'll show you this. So Chrome. So, you know, these are just from Project Maths. You've got these as well. So you can actually practice these at home if you want. That's not the one, that's another one that I thought about. Can you see that for the first question, that was pretty straightforward. 87% of them got it right. Then the second one, which was really easy, 88% of the state got it right. The third one, which is not that much, it was 1.65 out of 2. And I think that those students that didn't get full marks forgot plus C. So never forget plus C. So that's the major thing of lesson number 3 that I put up. And then this last one, the common mistake was that they didn't find out how much the ball had traveled and then come back. All right. So be aware that a ball can travel, displacement is just from a certain point. Okay. So it can be further away from where it is. I actually have to go because I have to go on a PD. Any other questions? Oh, I've got to show you one more thing. I've got to stop share and show you one more thing. If you've got any questions, please let me know.
What's the work for today?
You've got plenty of work. Have you noticed that I've only got one more lesson to give you? There's 5 lessons up. So this was lesson number 2, I think, in the video. And I said what direction we were going, and I talked this through with Sam. And we got to this stage and it said V equals 0. So I said, therefore it is at the origin. That's what I said in the video. That is not true. Okay. So velocity talks about how fast and what direction we're going. If velocity equals 0, it doesn't mean that it's at the origin. What tells us that we're at the origin? If what equals 0? If displacement equals 0. So velocity equal to 0, what does that tell us? We talked about this earlier with answering one of the questions. It just tells us that it's stationary. All right. So if you can fix that up on your notes, if you've written that down already, just make sure that velocity only tells us what direction it's going and how far, okay? It doesn't tell us where it is on the map. That's displacement, okay? Any other questions?
Oh, we're in the back. Oh, my
No questions? All right. I'm going to have to knock you out because I have to do a PD all day. So
Have a
you'll
good
be
one.
working, I'll be working too. So
Bye.
any emails, I'll try and answer them as best I can. All right. Good job, Year 12. Peace.
Yeah.
Out. I'm going to see if I can end this meeting. I don't know how to do this. Stop it. Oh, there we go. See you later.